So we're going to look at the probability of this question here, which is, the syntax is really tough to understand. What it's saying is at least one, maybe I should write that as the word one. At least one, needs to be permanent. At least one number 3, maybe that'll help. One number 3 turns up when 3 die are rolled. Okay, so let's try to think of this situation where we have our 3 die. So we have a die 1, die 2, and die 3, right? And what we're looking for is at least one of them says 3, okay? Now, there is the possibility of having 2 of them say 3, and all 3 of them say 3. So we're going to talk about this concept, okay? So this is one situation. What I'm going to do is to... Is that really working there? Copy, paste. No, that's not what I want. Undo. I'm just going to redraw. So this, we'll call this situation 1. So I'll call it S1. In situation 2, we could have 2 3s show up and something else. Okay. Probably could have just got a picture of the die. In this one, we have 2 of them saying 3. And maybe this one says a 1. And then in situation 3, one of the die says the number 3, and then the other 2 just don't. They can say any other number, right? So we're going to talk about the probability of all these events happening. And essentially, with all of these, we have to add the probability from situation 1 to the probability of situation 2 to the probability of situation 3. Okay, so what is our chance of getting one of the dice? Sorry, I shouldn't have wrote that over there. Well, what's the probability of rolling a 3 out of a single die? Of getting exactly the number 3.
1/6.
1/6, that's right. Okay. Multiplied by what is the probability of doing it in the next one?
1/6.
Yeah. And then 1/6. So the probability in situation 1 of getting all of them to be this would be essentially multiplying all these probabilities together. So when we multiply them all together, we have 1/6 times 36. .216. So the probability of getting all 3 of them to be the number 3 is 1 in 216. Pretty rare event. Okay. Same idea here. Rolling a 3 is still 1 in 6. Rolling a 3 is 1 in 6. What about not rolling a 3?
5.
Yes, exactly. 5 in 6. Very different, this one. Okay. So in this case, we have a probability of getting 5 in 6. Or 5 over 216 when we multiply it all together. And then finally, this is a 1 in 6 times not getting it, which is 5 in 6, like we said, which is multiplied by 5 in 6 again. We know it's going to be 216 on the bottom, and on the top we have a 25% likelihood, or 25. Okay, so now that we set this up with our essential probabilities, technically what happens is we're going to name each of these. We'll call this guy die 1, die 2, and die 3. Well, situation 1 can only happen one way. All 3 of them say the number 3. So that's the only number of possibilities for situation 2. Or sorry, 1. Situation 2 can actually happen 3 different ways. And in the one we've drawn out, it's when die 3 is not the number 3. But I could do the exact same thing where that happens to die 2. The probability is the same, but it's technically a little different. It's a different situation. A different die didn't end up as 3. Okay? So with that being the case, that also means that could be the case where die 1 doesn't end up as a 3. Okay? So what that's saying is there's actually 3. So times 3. There's 3 different ways we can end up with this situation, which means we have to add this probability. So we have to multiply this by 3. This probability here technically happens 3 times. And is it making sense when I say that? The situation? So essentially this situation, in this case, die 3 was the one out. But there's also the possibility of die 2 being the one out and die 1 being the one out. where the other two are the numbers 3. So there's actually 3 different situations. So this happens 3 times. And with that being said, situation 3 is identical. The same thing. In the first case that we did, the probability of only one of them being a 3 is 25 and 216. Okay? And in that case, we drew it as die 1. But that could also happen where die 2 is the only one that's a 3. Or die 3 is the only one that's a 3.
Okay.
Okay? So what that means is that also happens 3 times. So there's 3 different ways of this situation we're happening now. So what that means is, truly, and I should have wrote it this way, though it would have been a little disjointed. There are 1, 2, 3, 4, 5, 6, 7 different ways we can get at least 1 3 turning up. It's a lot of information, okay? So what that means then is we are going to add all of these denominators up. Okay, so we know all of the numerators. We know the denominator is 216, because when we add, we keep the same denominator. We have to add all our numerators, so we'll do a little mental math. 25 and 25 is, do you know? Yeah, plus another 25.
75.
Yeah, plus 5 is
80.
80,
85. 90. 91.
91. So the probability of getting at least 1 3 turning up is 91 and 216. Okay? So, this is a hard way of doing it. A very simple way of doing it is thinking of the very opposite effect. Now, I've already written in some of the information. I'm going to take that out so we can do it together. Okay? Let's take this out. Oh, no, don't go laggy on me. Okay. So, in the situation I'm doing now is when let's do the opposite. We'll talk about never rolling a 3. And we talked about this already. What's the probability of never rolling a 3?
5.
Yeah, 5 over 6. So let's multiply all of those probabilities together. So this is the opposite. Okay, so this is not actually what we're looking for. And when we multiply it, we actually get 216, and 3 5s is 125. So the probability of not getting that is 125 out of 216. Okay? But remember, we're looking for the probability of, I'm going to call it 1 number 3. Okay? So the probability of 1 number 3 plus the probability of, and I actually have to say at least, that's very important, at least 1 number 3 plus the probability of no number 3s is equal to 100%, right? It's either the probability of the event happening or the probability of the event not happening. Together, they're all possible events. It's 100%. 100% can kind of be written as like 216 out of 216, right? It's just another way of saying the number 1. Okay? And the reason I've written it that way is I want us to realize here that if we're trying to find, in this case, the probability of at least 1 3, and the actual probability we have found is of no number 3s, we have to do a little bit of subtraction. So 100% is 216 over 216, which is really just the number 1. Okay, are you okay with that idea?
Yeah.
Yeah, okay. So it's equal to number 1. We're trying to find the probability of at least 1 number 3. So I'm just going to go P of A, L, O, 3. At least 1 3. Okay. What's the probability of no number 3s? What's the actual probability here? Do you remember what it was? We did it right.
91 over 260.
That's of this. Okay, so let's pretend we've never done this, and this is how we started the question. What was our probability of not getting a 3?
125.
Yeah,
260.
125 over 216. Okay, we want to isolate our variable, which is probability of, and I've just given it a funny symbol. Okay, so I gotta move this to the other side. So our probability of ALO3 is equal to 1 subtract 125 over 216. Now we need to have common denominators, so it's 216 subtract 125 over 216. Is this making sense how I changed 1 into that?
Yeah.
Yeah. Okay. And then we subtract. Well, we know it's going to be out of 216. And it turns out that 216 subtract 125 is 91. And we were isolating for the probability of at least 1 number 3. So two very different ways about going about it. And this one I had to develop 7 different situations. And this one I developed just the one situation where it doesn't happen, and I subtracted from the value of 1. Okay. This one is much easier to work with, but we just have to have a general idea of how that works. It is a little different than what we're used to seeing.